Okay, so let's continue with the tutorial. So number example or tutorial if you want to. So here is our question. Okay, it says describe the um, the solution set of the following linear system of equations. Okay, so here is our system. We have minus x plus 2y plus z plus w equals to 3, and we have 2x, forgive my x's, 2x minus 2y plus z minus w equals to minus 10, and we have minus x plus 4y minus z plus 2w equals to 14. Okay, and finally x plus 2y plus w equals to 4. Let me check just to make sure that I have everything right. X, okay, well, yes, that's good. Okay, good. Let's just double check before we start the computation. Okay, and x plus 2y plus w equals to 4. So we are asked to describe the solution set. Let me write here the solution, okay, or the computation. So here is, I'm going to rewrite it here. So step number 1, if you recall from the previous video, the lecture, to be able to describe the solution set, step number 1 is to bring the system to its echelon form. And step number 2 is to parameterize it. So let's start with step number 1, to bring the system to echelon form. Okay, so let me write it here. Okay, bring the system to its echelon form. That means perform Gauss method or Gauss elimination. So, and in this tutorial, I'm going to fly through Gauss method because I have gone in depth into them in some previous videos. Okay, in the previous video. So if you don't recall how to perform Gauss's method, yeah, watch the previous tutorials. Okay, so here we have minus x plus 2y plus z plus w equals to 3. 2x minus 2y plus z minus w equals to minus 10, and minus x plus 4y minus z plus 2w equals to 14, and x plus 2y plus w equals to 4. Okay, so what do we do? Maybe let me change. No, I don't have to change colors for that because I think we are now pro in Gauss's method. Okay, so what you have to do, use this leading variable, the minus x, to eliminate all the terms, all the x terms in each of the rows below the first row. So I'm going to use minus x to eliminate the 2x here in the second row, and to eliminate the minus x in the third row, and to eliminate the x in the fourth row. Is that okay? So I'm going to fly through Gauss's method. So row 1 plus row 2, and okay, so that leads to minus x plus 2y plus z plus w equals to 3. And we have here we are going to eliminate the second row, so we have here 2y. Okay, so minus, so that's 4, that's 2y, sorry, that's 2y plus 3z, okay, 2 plus w equals to 6 minus 10, which is going to be equal to minus 4. And then I'm going to use the minus x to eliminate the minus x in the third row. So what I have to do here is minus row 1 plus row 3. Okay, minus row 1 plus row 3 will give me minus row 1 plus row 3. So that's 0 for the x. We eliminate the minus x there. So here I'm left with the 2y. Okay, minus 2z and plus w equals 11. Okay, so okay, I'm going to write to keep the third row, because let me write here plus 2y plus w equals 4, and I'm going to do it here. So let me use the first row to eliminate the third row. So what I have to do is just row 1 plus row 4. Okay, so I have row 1 plus row 4 will help me eliminate the x in the fourth row. So we have minus x plus 2y plus z plus w equals to 3. I have 2y plus 3z plus w equals to minus 4, and 2y minus 2z plus w equals to 11. And here, so we are left with the so we have here, what do we have here? We have 2 plus 2 is 4y. Okay, we are left with the 4y, and here for y we have plus z, okay, plus 2w equals 2, 3 plus 4 is 7. Okay, so now we have done with the first leading variable. Now the second leading variable is in the second row. Okay, the leading variable in the second row is y, so I'm going to use this 2y to eliminate the y's below it. Okay, so what I have here is I have a minus row 2 plus row 3. We lead to here we still have minus x plus 2y plus z plus w equals to 3, and we still have the 2y plus 3z plus w equals to minus 4, and then so we have minus row 2 plus row 3 minus row 2 plus row 3, so we have here minus 5z equals to so here we have a minus row 2, okay, equals to 15, and we need to use the 2y to eliminate the 4y, okay, in the fourth row. So you have a minus 2 row 2 plus row 4. So minus 2 row 2 plus row 4, we are left with so here minus 2, here minus 6 plus 1, so we have minus 5z and minus 2w plus 2w is 0, so equals to minus 2 minus 8 plus so 2, so minus 8 plus 7, okay, so minus 2 multiplied by minus 4 is 8, okay, so 8 plus 7 is 15, okay, and let's do the last part. What we have to do is the leading variable in the third row is z, so we are going to use the minus 5z in the third row to eliminate the minus 5z in the fourth row. Okay, so we have minus row 3 plus row 4 should give us the final echelon form. Let me write it in another color. So we have minus x plus 2w plus z plus w equals to 3. We have 2y plus 3z plus w equals to minus 4. And we have 5 minus 5z equals to 15. So minus 5, z is 5z, minus 5z is 0, minus 15 is going to be minus 15 plus 15 is going to be 0. Okay, so here we have 0 equals to 0. How do we know that the solution set of this system has an infinitely many solutions? Because we arrive, number one, at echelon form, and we have no contradictory rule. Okay, so 0 equals to 0 makes sense, no contradiction. And there is a row, or there is at least one variable that is not leading a row. Okay, so at the fourth row, we don't have the fourth variable, which is w, leading the fourth row. So w is leading no row. Okay, so step number 2, I don't know if I need to go to, if you remember how to describe the solution set, is we need to bring it to the echelon form that we have done. Now we need to parameterize it with the free variable. Parameterize means write the leading variable in terms of the free variable. Okay, so let me go to next. So step number 2, we said parameterize with the free variables. So we need to parameterize with the free variables. Okay, so if you recall our echelon form, we have minus x plus y plus z plus w equals to 3. 2y plus 3z plus w equals to minus 4. Minus 5z equals to 15, and 0 equals to 0. Okay, so we have to do, so let's pick the first, the third row. Okay, so here, let me do a big dot here. We have minus 5, so we are going to do a type of back substitutions, okay, with the free variables inside them, but it's back substitution. Minus 5z equals to 15, so that means z equals to minus 3. Okay, now the second variable, we have 2y plus 3z plus w equals to minus 4. So we have 2y equals to minus 4 minus 3z minus w. Minus 4, we know the value of z, but we don't know the value of w. So if you recall, we are writing the leading variable, so that if you pick the third row, the leading variable is z. So we are going to write z in terms of, here we have no other variables. In the second row, the leading variable is y. So we are going to write y in terms of the other free variables. So in the second row here, the leading variable is y, and the free variables are w, z, and w. They are free. So that's what I have written here. If you see, I'm writing the leading variables in terms of the free variables. Okay, the leading variable. That's the leading one. Okay, in terms of the free variables. So minus 3, we know the value of z, so minus 3, and we don't know the value of w. So we have here minus 4 plus 9 Okay, minus 4 plus 9 minus w, which is going to be equal to 5 minus w, that's 2y. That means y equals to 5 over 2 minus a half of w. Okay, that's our y. Now the first row, the first row is minus x plus 2y plus z plus w equals to 3. So we need to write the leading variable, which is L here, in terms of the free variables. Those are the variables that are not leading, okay? We have minus x equals to 3 minus 2y minus z minus w, which is going to be equal to 3 minus 2. We know the value of y, that's 5 over 2 minus a half of w, okay? Minus z, we know the value of z, which is minus 3, and we have minus w. So that is 3, yeah, minus 5, and 2 and 2 cancel, plus w, plus 3, minus w. So here we have 6 minus 5, which is 1, and w minus w, which is 0. So we have minus x equal to that. That means x is equal to minus 1. Okay, so the solution set, so that's, here is the solution set. We are just describing. This is not the final answer. In the next few videos, or at some point in this chapter, I will give you the final answer, where we will be writing the solution set, the final solution, okay, or the final answer in by using vectors notations, okay, and it's easier to understand that way. So solution set. So describing the solution set using vectors notation is very interesting. So we have x equals to minus 1, and we have y equals to 5 over 2 minus a half of w, and we have z equals to minus 3. Okay, so because of that w there, the solution set has infinitely many solutions, because w can take any value in R. Okay, so I'm going to stop here for the tutorial, and just a quick reminder that our question was to describe the solution set of a linear system. And if you recall from the lecture, we have said to be able to describe the solution set, we have to go through 2 steps. First of all, bring the solution set, the system, to echelon form, and step number 2, parameterize it with the free variables. Okay, and that's what we have done here. First of all, we have performed a Gauss's method to be able to bring the system to its echelon form, and then step number 2, you parameterize each leading variables with the free variables. Okay, so just a quick check, and yeah, I think we are all set for today, and thank you for watching, and see you in the next video. Okay.